Starter 3 is over representing functions, and question number 1 asks us, is the set of ordered pair below a function? Explain why or why not. Remember, with a function, I'm just giving you an example of a really basic one. Let's say this function is x plus 2. That means whatever your input, x is, you're going to add 2 to it, and that your output is what's going to come out and be your y. So if I put in a 3 plus 2 is 5. My input is 3 plus 2, my output is going to be 5. So that means I could sit here and I could put in 3s all day long. Guess what? I'm always going to get 5s out for my output. So if I have the same input that goes into my function, I have to have the same output that comes out. If I constantly put in 3s, I'm constantly going to get 5s coming out of that function. That's the case for any function. If the same input goes into it, the same output has to come out. Let's say, for example, it's 3x. So I put in a 4. 3 times 4 is 12. I can be putting in 4s all day long. 12s are always going to come out. So the definition of a function is that if you, in layman's terms, if you have the same input, you have to have the same output. In other words, same x's, you have to have the same y's. So let's look at our example and see if it's a function. Here I've got a 1, a 1, a 1, and a 1, all the same input, because remember the x comes first in an ordered pair. That's okay as long as you have the same y's to come after it, but look, we don't. They all have a different output. So this is not a function because we have some of the same, actually all the same x's or input, whatever you choose to say, with different, I'm just going to abbreviate here, output. Number 2, what value for x would allow the set of ordered pairs to be a function? Again, if we have the same x's, we have to have the same y's. So, in order for it to be a function. So let me look here. 2 and 3 and 1, they're all different x's. So if all your x's are different, you automatically assume it's a function. But what would happen if I substituted this 1 in for x? So instead of an x, now this is going to be a 1. Let's check out A. Well, now these two have the same input, but they have different output. This one has an 8 and this one has a 4. So therefore, A can't be right, because if k were going to be a 1, if x were going to be a 1, then it wouldn't be a function anymore. What if I put a 2 in for x? Instead of an x, now that's a 2. Well, that one won't work either, because here we've got a 2, so that gives us the same input, which is okay as long as it has the same output, but it doesn't. That one's a 5 and that one's an 8. So x can't be a 2 either. What if x were a 3? Well, same deal. Here we have the same input with different output. So C can't be right either. But our final choice, if x were a 5, then we would still have all different output. So remember, as long as we would all have different input. So as long as all your inputs are different, it's okay. You can assume that it's a function. So number 2 should have been D.